I transcribe hours of audio every week, and I have never once paid a transcription service to do it. It all runs on my own home GPU for free after the hardware I already own, and none of the audio ever leaves my machine. The tool that makes this possible is Whisper, an open speech-to-text model that you can run entirely locally. It is genuinely good, often as good as the paid services, and once it is set up, it just works. Let me walk you through the exact workflow I use: the install, picking the right model, running it on a file, and cleaning up the output so it is actually usable. First, let me tell you why this matters beyond saving a few dollars. Transcription touches sensitive stuff. Interviews, meetings, voice notes, personal recordings. When you upload that to a transcription service, you are handing your audio to a company and trusting their policy. Running Whisper locally means none of that leaves your computer. That privacy alone is the reason a lot of people switch. On top of that, you get unlimited volume. Paid services charge per minute, so the more you transcribe, the more it costs. Local Whisper has no per minute charge at all. You can transcribe 100 hours and the only cost is the electricity to run your GPU for a while. Let me explain what Whisper actually is so the choices later make sense. It is a speech recognition model that listens to audio and writes out the words, with surprisingly good handling of accents, background noise, and natural speech. It comes in several sizes, from tiny to very large, and the size is the main decision you make. Bigger models are more accurate, especially on hard audio, but they need more memory and run slower. Smaller models are fast and light, but make more mistakes on tricky speech. The whole skill of using Whisper well is matching the model size to your audio quality and your hardware. That is the lever you are pulling. Now the install. The cleanest path for most people is a fast, optimized version of Whisper that is built specifically to run efficiently on a GPU. You install it through Python, typically with a single package install command, and you make sure your graphics card drivers are current so the GPU acceleration works. There are graphical apps that wrap all this in a friendly interface if you never want to touch a terminal, and those are a fine starting point. But I run the command line version because it slots straight into my automated pipeline, where audio comes in and clean transcripts come out without me clicking anything. Either way, the install is a one-time setup that takes a few minutes. Once it is installed, running it is genuinely simple. You point Whisper at an audio file, you tell it which model size to use, and it transcribes. The first time you use a given model size, it downloads that model, a one-time thing, and after that the model lives on your disk and runs offline. You give it an MP3 or WAV or most common audio formats, it chews through the audio and it writes out the text. It can also produce timed output, where each chunk of text is stamped with when it was spoken, which is exactly what you need if you are making subtitles or captions for a video. That timing comes out of the box, you just ask for it. Let me be honest about speed, because this is where the GPU matters enormously. On a decent graphics card, Whisper transcribes far faster than real time. An hour of audio can be done in a handful of minutes with a mid-sized model. On a CPU-only setup, the same job can take many times longer, sometimes longer than the audio itself. So if transcription feels slow, the first thing to check is whether it is actually using your GPU or quietly falling back to the CPU. The optimized versions are specifically built to keep this fast on the GPU, which is why I recommend them. When it is running on the card properly, the speed is genuinely impressive and it stops being something you wait around for. Here is how I choose the model size in real life. For clean audio, a single clear speaker, good microphone, low noise, a medium model is plenty and it is fast. For hard audio, multiple speakers, accents, background noise, phone call quality, I step up to a larger model because the accuracy gain is worth the extra time. And for quick throwaway transcripts, where I just need the gist, the smaller models are fine and nearly instant. The mistake beginners make is always reaching for the largest model, thinking bigger is always better. It is more accurate, yes, but it is slower, and on clean audio, you often cannot even tell the difference. Match the model to the difficulty of the audio. Let me set honest expectations about where accuracy breaks, because no transcription is perfect, local or paid. Whisper struggles with the same things humans struggle with. Heavy crosstalk, where people talk over each other. Very heavy accents combined with poor audio. specialist jargon, and unusual proper nouns it has never really heard. And it will occasionally invent a plausible sounding phrase during long silences or very noisy stretches, which is a known quirk you should watch for. So for anything where the exact words matter legally or professionally, you still proofread. Local Whisper gets you a very strong first draft, often 95% or better on good audio, but the last bit of accuracy still needs a human eye. Now the part that makes it actually usable, cleaning the output. The raw transcript is a wall of text or a stream of timed lines, and it usually needs a little work. This is where I chain in a language model. I take the raw Whisper transcript and I pass it to a local model with a simple instruction. Fix the punctuation, break it into paragraphs, clean up the obvious filler words, but do not change the meaning or invent anything that turns a rough machine transcript into something readable in seconds. And because that step is also local, the whole pipeline stays free and private end to end. Audio in, clean readable transcript out, nothing leaves the machine, nothing gets billed. Let me show you how this becomes a real pipeline rather than a manual chore. I have a folder where audio files land, a script watches that folder, and when a new file appears, it runs Whisper on it, then runs the cleanup model on the result, then drops the finished transcript next to the original. I never touch it. Recordings come in, transcripts appear. For my own video work, this is how the captions get made. The voiceover audio goes through this exact path and comes out as timed caption text. Doing that against a paid service at the volume I run would be a real recurring bill. Doing it locally is just my GPU working for a few minutes per file. Let me talk about the different output formats, because picking the right one saves you a lot of fiddling later. Whisper can give you plain text with no timing, which is what you want for a readable transcript. It can give you time segments, where chunks of text are stamped with start and end times, which is what you want for subtitles. It can produce the standard subtitle file formats directly ready to drop onto a video. And it can give you word-level timing, where every single word has its own timestamp, which is what you need if you want captions that highlight word by word as they are spoken. Decide what you are making before you run it, ask for that format, and you skip a whole conversion step. That one choice up front keeps the workflow clean. Let me explain the speaker question honestly, because people expect Whisper to do something it does not do on its own. Whisper transcribes what is said, but out of the box it does not tell you who said it. It gives you the words, not the labels of who spoke each line. Figuring out who is speaking is a separate task, sometimes called speaker separation, and it needs an additional tool layered on top. There are projects that combine Whisper with that capability, and they work, but they add complexity and they are not perfect. So if your audio is a multi-person conversation and you need to know who said what, set that expectation now. Plain Whisper gives you a clean transcript of the words. Attaching names to those words is extra machinery you bolt on. Let me share the language angle because it is genuinely impressive and underused. Whisper handles many languages, not just English, and it does it well. You can transcribe audio in another language into text in that same language. And it can also translate as it transcribes, taking speech in one language and giving you the text in English. That translation is rough, a first pass rather than a polished translation, but for understanding what was said in a recording in a language you do not speak, it is remarkably useful. So if you work with audio across languages, you have a free, private, local tool that both transcribes and roughly translates all on your own machine. That capability alone justifies the setup for a lot of people. Let me give you the honest guidance on the invented phrase problem, because it is the one quirk that can actually bite you. During long silences, or stretches of music, or very noisy audio with no clear speech, Whisper sometimes outputs a plausible sounding phrase that was never actually said. It is filling a gap with its best guess. This is rare on clean speech, but more common on messy input. The practical defenses are simple. Trim out long silent or musical sections before transcribing. And for anything where accuracy is critical, scan the transcript against the audio at the spots where the timing shows long gaps, because that is where these inventions tend to appear. Knowing this quirk exists is most of the protection. You stop trusting the transcript blindly, and you spot check the risky stretches. Let me put a real cost comparison on the table so the decision is grounded. Paid transcription services typically charge by the minute of audio. That is cheap for an occasional file and reasonable for moderate use. But it scales directly with volume, so if you transcribe many hours every week, that bill becomes a real recurring expense month after month forever. Local Whisper has no permanent charge at all. After the hardware you already own, the only cost is the electricity to run your GPU for a few minutes per file, so the crossover is the same pattern as everywhere else in local AI. Light occasional use, the paid service is fine and simple. Steady high volume use, local is dramatically cheaper, and the more you transcribe, the more lopsided that gets in local's favor. A few practical tips that save real headaches. First, convert weird audio formats to a plain common one before transcribing, because clean input avoids strange failures. Second, if your audio has long stretches of silence or music, trimming those out first improves both speed and accuracy and reduces the chance of the model inventing phrases. Third, for very long recordings, the timed output is your friend because it lets you jump straight to any moment and check the transcript against the audio. And fourth, keep the model files somewhere with enough disk space since the larger models are several gigabytes each. Small things, but they are the difference between a smooth workflow and a frustrating one. Let me give you a real accuracy expectation by audio type because that drives every other choice. On a clean recording, one clear speaker, a decent microphone, quiet room, a good whisper model gets you well above 90% accuracy, often into the high 90s, close enough that proofreading is light. On a typical video voiceover, which is usually clean, it is excellent. On a recorded meeting with several people and a mediocre microphone, accuracy drops and you will be correcting more. On a noisy phone call or audio with heavy crosstalk, it struggles like any system would. So set your effort expectation by the audio quality going in. Clean audio is nearly hands-off. Messy audio means a larger model and more proofreading. There is no model that makes bad audio perfectly accurate, local or paid. Let me share how this fits into a real content workflow, because that is where it earns its keep for me. Every video I make needs captions, and captions need an accurate, timed transcript of the narrations. So the voice-over audio goes straight through Local Whisper with word-level timing, and out comes caption data ready to lay onto the video. It is fast, it is free, and because the audio is just my own narration recorded cleanly, the accuracy is excellent with almost no correction needed. Doing this for every video against a paid service would be a steady recurring cost. Doing it locally folds it into the pipeline at no marginal cost. That is the quiet kind of win local AI delivers. Not a flashy demo, but a real recurring expense erased. So to bring it together, install an optimized Local Whisper. Make sure it uses your GPU. Pick a model size that matches how hard your audio is. Medium for clean, larger for messy. Run it on your file and ask for timed output if you need captions. Pass the raw result through a local model to clean it up, and if you do this a lot, wire it into a folder watcher so transcripts just appear. That is the whole system, and it costs nothing per use after the hardware you already have, with every second of audio staying on your own machine. Owning your transcription instead of renting it is one of the most clearly worth it local AI wins there is, and it is exactly the kind of practical, honest workflow I build on this channel every week. If that is your thing, subscribe and follow along. Subscribe for more AI builds.